Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I welcome you to the next session of the C Refresher series. Today I'm going to give you all a review of the concept that deals with pointers. Pointers in C. Pointers in C is a topic which majority of the students are always afraid of. And most of these afraid students ask me, why on God's earth can't we write programs without using pointers? So the question is, why pointers? Students, we use pointers because by using pointers we can write faster and more efficient code using pointers and the arithmetic because they are more closer to the hardware. Secondly, they support dynamic memory allocation. Third, we can protect the data that we pass to functions as pointers. Moreover, we can pass complex data structures to function without incurring large overhead on the stack. And there are other advantages as well. So first of all, let me review the very basics of the pointers, that is, how we can declare and how we can use pointers. Suppose that we declare an integer type of variable containing 54. To create a pointer, the syntax is something like this. In memory, if I draw this, assuming that we have the stack over here, and remember, we know that we have the high addresses and the stack grows downward. Once we declare a variable I, let's suppose that this variable is created at address 100. The name of this address is I, and it contains 54. And we all know that on most of the machine, the integer variables take 4 bytes. Then we are going to create a pointer variable. This variable will also be created on the stack at address, let's suppose 86. Rather 87, because we have 88, 89, 97, 98, 99 and 100. So this will be 96 PTR. So this contains actually the address of that. That is, let me change color. This is a pointer that is pointing to this memory location. As far as the size of the pointer is concerned, it is the same regardless of the pointer type. Whether we have a pointer that is pointing to integer data or character data, it will have the same size. And on most of the machine, it is again 4 bytes, or 32-bit, maybe 64. That depends on the machine hardware, operating system, and the compiler. Over here, you see two symbols. One is the asterisk symbol. The asterisk symbol is an overloaded operator that can be used for for three purposes. One is to declare the variable as pointer, as we have used over here. The other is to dereference a pointer as indirection operator. We will soon use it. And the third as an arithmetic operator for multiplication. The other operator you see over here is the ampersand. The ampersand is the address of operator and returns its operand address. And over here the operand is I. The operand is I. So it will return the address of I in this variable on the left side of the assignment statement. Pointer type must be same as the type it is pointing to. However, you can use a void pointer that can keep the address of any type of variable that is used for polymorphic behavior. Let us move on to the terminal and see a program that describes the basic usage of pointer variable and displays the addresses. I have written a program for you. You can see this program. It creates a variable, then it creates a pointer and places the address of this variable I in this pointer. We have displayed the value of this, then we have displayed the address of I, and then we have displayed the pointer, the address of the pointer. Over here we have used asterisk as a dereference operator, and in the last two lines I've checked up the size of the pointer variable and the size of I. Let me compile and run this program. You see this is the address of I, which is the same as contained by the pointer variable. And the size of the pointer on my machine is 8 because it is a 64-bit machine, 64-bit OS, and the size of the integer variable is 4. Okay, let me run this program again. You can note once I run this program again, the addresses are changed. Over here, the address of I was the last 4 digits are 984C, but over here it is 68AC. Students, in old operating systems, whenever you load a process, it generates the same logical addresses. Might be, if you use it on your machine, it might generate same addresses no matter how many times you execute the program. This was said to be a security loophole that allows injection of malicious code. And now most of the operating systems like Linux, which we are working on, provide what is known as address space randomization. Let me disable this address space randomization. Randomize VA space. Let me give it a value of 0 and let me be root to execute this. And now let me execute this program again, and execute this program again, and execute this program again. Now you can see, no matter how many times I execute this program, the same addresses are generated. The logical addresses are the same. Remember, gentlemen, the addresses displayed over here are the logical addresses. They are not the physical addresses. And the logical addresses normally do not change no matter how many times you load and execute your program, until the operating system has enabled the address space randomization. Let me enable it again. Let me clear screen and let me move back to the terminal again. After having seen this, let me move on to the other terminal. Let me tell you a concept of null in C. Concept of null. It is a bit confusing because Null is a concept that is used for null statements in C. And a null statement in C is a statement with a semicolon only. It is also used for null strings. A null string in C is an empty string or a string containing no character, just the ASCII null character. Then we have the ASCII null with a single L, which is defined as a byte containing all zeros. You can check out by writing the ASCII command over here. This is the ASCII null character NU single L with the decimal value of 0. And finally is the null pointer. Gentlemen, whenever you declare a pointer, like for example int asterisk ptr, this points to unknown memory location. Never dereference an uninitialized pointer. It is always better that whenever you create a pointer, you initialize it in the same line. If you can't, you initialize it with null, where null is a macro defined in stdio.h that says void asterisk 0. Many times you can write like this as well. Some people get confused by this because we are used to of using overloaded operators. We are not used to of overloaded operands. 0 is an overloaded operand. If you do like this, it means it is automatically casted to a null pointer. And if you do it like this, it is normal integer value. One more thing that you might come across later is that you will come up something like this. If ptr, then this, else this. Well, gentlemen, if this ptr contains null, it will be interpreted as binary 0, which represent a false in C. So therefore, if this contains null, this portion will be executed. This is equivalent to if ptr is not equal to null, then this, else this. This is another thing which confused my students many a times. Let's move on to the terminal again and see this. So I'm just showing you this code so that you can just type and run it to have a clear understanding of what a null pointer is. Before moving ahead, please make sure that you have a very fair idea of what a null pointer is. Let me move ahead to the next board and talk about something about pointer arithmetic. Pointer arithmetic. Well, there are several operators that can be used with pointers. We have seen the dereference and the address of operator. You can always use comparison operators with pointers like double equals, not equal to, less than equal to, greater than and greater than equal to. most commonly you use the plus and the plus plus operator, increment, pre-increment and the post-increment operator. And you can always use the binary minus and the decrement operator, pre and the post. Remember, whenever you add or subtract an integer to a pointer, the amount added or subtracted is the product of the integer times the number of bytes of the underlying data type. Let me write it down. Int I is equal to 54 and int asterisk ptr is equal to ampersand I. If I do ptr plus plus, so I am adding 1 to the contents of ptr, the address. It will add 4 in it, 1 multiplied by 4. If I do ptr plus 2, this means 2 into 4. If I do ptr, let's suppose minus 3, it means 3 into 4. This will be subtracted this time. So let me say again, whenever we add or subtract an integer, to a pointer, the amount added is the product of integer times the number of bytes the underlying data type takes. So this integer takes 4 bytes, so this pointer will be subtracted with the value of 12, not 3. Please practice this before you move ahead. Another point that you should keep in mind is that if I do something like this, this will not increment the address, rather this will first dereference the pointer and then it will add 1 in it. If I do something like this, this will again dereference the pointer and will add value 2 in it. Please write down a basic program that shows you the working of the plus and the minus operator with pointers. Let me talk about the const keyword with pointers now. Dear students, you all have used the const keyword to make a variable read-only, which makes the compiler generate optimized code. You can create a const variable by writing something like this: int const a is equal to 10, or maybe you write something like this: const int a is equal to 10. After writing any of these two lines, this a will be declared in the read-only memory. Now if you do something a++, this will generate an error. Now let us use the const keyword with pointers. Before I move on to the terminal, let me write down the summary of the 4 possible types of pointers, or 4 possible usages of const keyword with pointers. Change color. The first is a pointer to non-constant data. Non-const data. In this case, the pointer is modifiable and the data is also modifiable. This is a normal scenario. Let me show you the program that deals with this. This is the normal scenario. We read it as PTR is a pointer variable that points to integer data. Remember, gentlemen, it's quite easy to read it out from right to left. PTR is a pointer variable that points to integer data. So if this is the case, you can increment the data as well as you can increment the address, which I have mentioned over here. The pointer is also modifiable and the data is also modifiable. Let me compile this program and run it. It will run with success. The other category is pointer to constant data. This means the pointer is modifiable, but the data is not. Let's see a program that explains this concept to us. Okay, I will read this as PTR is a pointer variable that points to constant integer. You can always declare it something like this, which says PTR is a pointer variable that points to integer data that is constant. Now the data is constant. That means this line will generate an error because over here we are dereferencing the pointer and increment the value. That is, we are modifying the data. We cannot do that. Let me do GCC. And you see, it has generated an error on this line. Well, the third option is that we have a constant pointer that points to non-const data. That means we cannot modify the pointer, however we can modify the data. Let's see the example. Okay, let me read this for you. This says PTR is a constant pointer. PTR is a constant pointer that points to integer data. So this time the pointer is constant, so we will get an error over here because over here we are trying to increment the pointer value. You see? And the last option is constant pointer to constant data. And in this case, neither we can modify the pointer nor we can modify the data. Let's see the code for this. Okay. So I will read it out as PTR is a constant pointer that points to constant integer data. It is the same as this, which says PTR is a constant pointer that points to integer data which is constant. So in this case, we cannot modify the data as well as we cannot modify the pointer. So we'll get error on both of these lines. Well, gentlemen, we normally use these pointers and the const keyword with them when passing values to functions. And we do not want that the function should change the data contents, or maybe at times should not change the address contained in those pointers. Okay, so after this overview of the usage of pointers, let us now move about arrays. Arrays and pointers are very much related to each other. Let me talk them one by one. Let me first talk about 1D integer arrays. And pointers. Let me relate both these topics together. We all know that an array is a finite collection of similar elements stored in adjacent memory location, which can be accessed by an integer subscript. The syntax to declare an array is I have created as well as initialized an array. If I draw the memory layout of this, it will be something like this, that the name of this equation is ARR. It has 5 elements, 1, 2, 3, 4 and 5, and the first element is at index 0, then 1, then 2, then 3 and then 4. If this is an integer type of array and we assume that this is the address 100, that means this address will be 104, this address will be 108, this address will be 112, and this address will be 116. Well, to access the elements of an array, we can always write down a loop which says for, let's suppose, I is equal to 0, I is less than the number of elements this array has, it is 5, and you can write down any output function, formatted or unformatted. Let me use printf. So for the first time we will get ARR sub 0, then 1, then 2, and then 3, and then so on. Well, gentlemen, you can use this array subscript as well as, if you want, you can instead of writing the above line, you can write this line, which is saying ARR plus I, and then it is using the dereference operator. Remember, for the first time once this loop runs, ARR will have 100 and it will add a 0 in it, which we get 100, which is the address this. Next time we have ARR plus 1, and we know that it will be actually 4, so 104, which is this address. Next time it will be 100 plus I will contain 2 into 4, which is 108, which is this address, and so on. Remember, you cannot do ARR is equal to ARR plus I. However, this is very much allowed. So you can use the subscript operator, or you can use pointer arithmetic to display them. At the same time, gentlemen, other than using the array name to access the elements of an array, we can use a pointer variable as well. For example, let me use blue color for this. I can create a variable like int asterisk ptr is equal to ARR. Array name is a pointer which will be assigned to this. So we have a variable over here which is ptr, which contains this address. And now I can of course write down a loop, the same above loop, and I can use printf %d \d ptr sub I, and I can always use the pointer arithmetic way of doing it, that is ptr plus I asterisk, and same thing over here. Remember, using the subscript operator with the array name is very convenient, but you must know how to do this, because in case of heap, most of the time we do this. Whenever you access array elements using pointer, it needs two read operation: one to read the contents of the pointer, and second to read that address, that is the value of the array element. On the contrary, if we are using this, because array name is a pointer, so we need only one read operation. Let me see if I have a code for this. 1D integer arrays. Oops. You can just have a view of the code. You can use the array name and the subscript I have told you. You can use the array name and you can do pointer arithmetic. You can use pointer with the subscript, and you can use the pointer name with this. So let me compile this and show it to you. It will work perfectly fine. So after you have seen this, let me move ahead and talk about the 2D integer arrays. It is very important to understand the concept of 2D integer arrays. So let me move on to the board, and on the board let me do this. Let me talk about the 2D integer arrays. And pointers. A 2D integer array is actually a 1D array of 1D array, or you can say a multidimensional array is an array of arrays. The syntax to create it is something like this. Let's suppose I say matrix. We have two subscript operators, and over here we write something like this. I have declared and initialized the array. Over here we have the first subscript represent the rows, and the second subscript represents the columns. As we all know that C is uses row major representation for this. By row major I mean the linear view is something like this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Let me rub the remaining part. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And remember, students, by row major means the first row is stored sequentially first. This is the first row, and then this is the second row, then this is the third row, and this is the fourth row. We have 4 rows: 0th row, first row, second row, and the third row. Some people feel convenient if it is represented in actually a matrix form. something like this. We have 4 rows and we have 3 columns. Column 0, column 1, column 2, row 0, 1, 2 and 3. Here we have rows and here we have columns. I can say that this is the 0, 0, this is 1, 0, this is 2, 0, this is 3, 0, this is 0, 1, 1, 1, 2, 1, 3, 1, and this is 0, 2, this is 1, 2, 1, this is 2, 2, and this is 3, 2. And the values inside are, of course, 1, 2, 3, the first row, 4, 5, 6, the second row, 7, 8, 9, the third row, and 10, 11, 12, last row. As far as the addresses are concerned, if I say that this is address 100, this is address 104, 108, 112, 116, 120, 124, 128, 132, 136, 140 and 144. Well, in order to access the elements of the array, we can write 2 loops. The outer loop will iterate through the rows. The inner loop will iterate through the columns. And then we can always write down something like this: printf arr sub I sub j. Well, we can always use pointers. Remember, if I write down arr, so this means the address, and the address is of course 100. And if I write down asterisk arr, this will dereference once and will again give the address 100. Remember, this arr gives the address of this 2D array, and this arr gives the address of this 1D array, this one. And if I do double asterisk arr, now this time it will dereference it and give me the value 1. Okay, now if I do something like this, arr plus 1. So remember, this time this one will not add 4, rather it will add 12. And we will get the address 112. If I dereference this, I will again get 112, this address. But this time this address will be the address of this 1D array. And if I use a double pointer over here, I will get the value 4. So writing this, I will get the value 4. Writing this, I will get the value 1. And writing arr plus 2, I will get the value 7. And if I write arr plus 3, I will get the value 10. So the question is, how can I access the rest of the elements? So let me change color. Let me show you how we can access 1, 2, this element, 6. So in order to access this location 1, 2, using pointers, what I can do is I can add a 1 so that I can move to this place. I dereference it Then I add 2, 0, 1, 0, 1 and 2. And after that I again dereference it. So remember, this is the address actually 112. 112. So once we add 2 in it, so actually we are adding 8 plus 8. So 112 plus 8 is 120. So we reach over this address. You can always try the size of operator on this matrix. If I do something like this, I will get 48. And if I do something like this, I will get 12. And if I use something like this, double asterisk, I will get 4. So this will give me 48, that is 48 bytes, the total size of the matrix. This will give me 12, that is the size of one row, this one, and this will give me 4, and that is size of this one element. So gentlemen, you need to be very clear on to how a 2D integer array is laid out in memory. A little bit more about 2D integer arrays and pointers. You have two ways of referring to a 2D array using pointer. The option one is you use pointer to array. We assume that we have the 2D matrix defined on the previous page, and if I create a pointer to array, I can write something like this is equal to matrix, and this will have a pointer over here that points to this array. So it is read as PTR is a pointer to a 1D array of integers of size 3. PTR is the pointer to a 1D array of integers of size 3. Number of rows need not to be mentioned over here. Another most common approach is arrays of pointers. And we do something like this. And this says we have an array of pointers, 0, 1, 2, 3 pointers. And each pointer is pointing to this first row, second row, third row, and fourth row. So how we will read this? This will be read as PTR is an array of size 4. PTR is an array of size 4 whose elements are of type integer pointer. And of course you can initialize it like this. PTR sub 0 is equal to, let's suppose, matrix sub 0. PTR sub 1 is equal to matrix sub 1, and so on. Let me move on to the terminal and see if we have a sample code for this. Vim 2D integer arrays. So you see I've created a table. Instead of matrix we have the table, and you can traverse the elements using the subscript operator and the array name. You can traverse using the array name and doing pointer arithmetic as discussed on the board. You can create a pointer to array as I have mentioned, and you can traverse it using that, and you can use array of pointers and you can traverse that. So these are the 4 different ways in which you can traverse to the integer array. See, using array name and the subscript, array name and pointer arithmetic, using pointer to array and array of pointers. Well, gentlemen, after doing this, there is one more thing left, that is 1D character arrays. So 1D character arrays and pointers. Well, we all know that a string is a sequence of characters terminated with the ASCII null character. Remember, ASCII null character, this one, not NULL. You can declare an array like this. And initialize it. You can always do something like this. It is represented as something like this: PUCIT terminated by a null string, and it is of size, of course, 30. If you want to input a string, you can input it using the scanf function, the fgetS function, and you can input it by character by character. Input a string via the keyboard. We have discussed this in the terminal IO session as well. Let me simply write it down for you. Scanf percentage node of \n s. This way I will be able to accept spaces as well. And let's suppose that we have array something like this. We can use fgetS, name, let's suppose 100, std in. In this case, remember, you must not forget to replace the new line character with null, and you can always use this syntax to get the name character by character using getchar. So this loop will keep on running till we get a \n. It will keep on incrementing I, and you know I contains 0 in the beginning, and finally I think we should place a null. And similarly you can do the output as well. What you should not do is that you must not do something like this and do scanf. This will give a segmentation violation because you have not allocated the memory and try to input a string in it. So if you want to do something like this, you need to do malloc. Let me move on to the terminal and show you the 1D character array. So please go through, write down this program, type it and use it. I'm not explaining it much because most of the concepts have been discussed in the terminal IO session. We have declared the string, we have input the string, and we have seen the issues. And the last thing which I want to touch upon is the 2D arrays and pointers. 2D character arrays and pointers. Let's suppose that we have a list of names. Let's suppose character names. We have many names. Let's suppose we have 3 names. Each name is of length 29, excluding the terminating null character. Okay, let me have a break for Azan. Okay, let me represent this 2D character array in memory. We have 3 arrays, 0, 1, 2. Each is having a length of about 30. The first contains Arif space but terminated by a null. The second contains row by a null. Then we have Jamil terminated by a null. Okay, and it is names. We can always access this by entering in a loop. Let me show you how we can get input from a terminal in such an array. Simple, gentlemen. Let's suppose that we have the array having names, and we have not initialized it because we want to get input from the user via keyboard. So we enter in a loop which runs the row number of times and use any function. I'm using fgetS. You can use scanf or getchar. Names sub I. The size is 30. std in. Remember, fgetS places the new line character before the null. So we need to replace the new line character with null, and we can do that by using a function strchr, which is passed the string and the character to be searched, and it returns the address. Let's suppose character pointer q. So the strchr returns a pointer to char to the first occurrence of the character passed as the second argument, that is new line character, in the string passed as the first argument, and it returns null character if not found. So let me put an F over here, and if this is success, then I place a null character at that place. Let me use something like this. So this is how we can input strings, and we can display strings on the terminal. If you haven't understood this properly, please go through the terminal IO session. And let me move on to the next screen. And let me show you how we can use array of pointers with 2D character arrays. It is very common to use the array of pointers instead of 2D character arrays, and you can declare an array of pointers of size 3 to store let's suppose 3 names, and if I draw the memory layout of this, we have names 0, 1, 2, which contains pointers, and the first pointer points to this name, second to this name, and third to this name. Students, you must not do like this. Like character pointer names sub 3, and then you enter in a loop and try to get input from the user. This will give you a segmentation violation, because you haven't allocated any memory for these names, which you should, and we will do it in some later session when we will be talking about heap and the malloc family of functions. Let me move on to the terminal and see if I have code for whatever I have discussed with you. Yes, I have. So you see, we can declare something like this, and we can get input in the names, and we can display those names. Let me compile and run this program. 2D character arrays. So I enter 3 names. First is Arif Bhatt, second is, let's suppose, Rauf, and the third one is Muhammad Jamil. So these are the 3 names. And remember what I have said, that you should not do something like this, because you are not allocating memory for the names. You are just creating the array of pointers. And if I compile this, it compiles successfully, but once I give it some input, it gives the segmentation fault. Okay, so let me sum up today's session. Dear students, we started with declaring a pointer of a specific type, assigning it a memory address, and then we dereferenced that pointer. We also saw that the size of the pointer to data is the same regardless of the pointer type. We discussed the concept of null. Other than the dereference and the address of operator, we talked about the comparison operators and performed addition and subtraction on pointer values and pointer addresses. We also discussed the const keyword with pointers, seeing the 4 combinations, that is the pointer to non-const data, pointer to constant data, constant pointer to non-constant data, and constant pointer to constant data. Then we talked about the architecture of 1D and 2D integer arrays and have seen how we can access the elements using array name and subscript operator. Finally, we repeated the same for 1D and 2D character arrays. Dear students, there are still some more topics related to pointer that I want to discuss, and those are mainly related to pointers and functions, but I will touch them in some next session, inshallah. And I wish you all the best. Happy coding and Allah Hafiz. जहाँ का सबात है तुम ही से ऐ मुजाहिदो जहाँ